Okay, today we're going to talk about how we can solve a system of that's composed of a linear and a quadratic equation. So this covers the integrated algebra standard AG9, solve systems of linear and quadratic equations graphically. So that we're, using this standard to drive what we're learning today, we're going to use the graphing techniques in order to find a solution. So our vocabulary is quadratic and linear system. Now, when we have a quadratic and linear system, there are three possible types of intersections. Just looking at a parabola and a line, there could be 2 points of intersection, so these 2 points right here. There could be 1 point of intersection, so the line could just barely touch the parabola but not go through the parabola. And there could be no points of intersection. Okay, so let's use the graphing method in order to find these. So we're going to have to both graph the parabola using what we learned in the last lesson, and graphing the line, which we did in the units, a few units before this one. So first of all, we have x squared minus 6x plus 6. Now let's try to see if we can find the roots of this equation. So if I have negative 6 and 6 here, I can't think of anything that, let's see, there are no factors of 6 that add to negative 6. So I can't find or there are roots to this quadratic equation, but they're not integer values, so I can't use the technique of factoring. So let's go ahead and find the vertex then. Okay, my vertex is, so it's x is equal to negative b over 2a, and a in this case is 1 for the quadratic equation, b is negative 6, so I have the opposite, right? This negative here means the opposite of negative 6, so the opposite of negative 6 over 2 times 1. So it's 6 over 2, which is 3. So x is equal to 3 is the line of symmetry. Now I need to find, so I know that the parabola is symmetric about x is equal to 3. So I know that's my line of symmetry. But I don't know where along this line my vertex is. So I'm going to put 3 back into the equation here. So I have 9 minus 18 plus 6. 9 minus 18 is negative 9 plus 6, which is negative 3. So it's at 3, negative 3. So 3 and negative 3, which is right here. Okay, so there's the vertex of my system. Now I'm going to just use a few more values on the other sides. So let's try it when x is equal to 5. Let's figure out what this is. So we'd have, first of all, we know it's going to be pointing up because the leading coefficient is positive, it's 1. So I know if the vertex is below the x-axis and it's pointing upward, then somehow this is going to cross, it's going to cross the x-axis something like this. Okay, so there are real roots here. They just are not integer values. So I can't use factoring to figure that out. Okay, so let's just pick the value of x is equal to 5 and let's put it in the function up here. So we'd have 25 minus 6 times 5 plus 6. So 25 minus 30 plus 6 is negative 5 plus 6, which is 1. So 5, 1. Oops. So 5, 1 would be a point here. 5 and 1. So that means that, so this point is 2 to the right of the line of symmetry, so I can go 2 to the left along the same vertical line. So that's another point right there. Okay, now let me try 6 for a second. Here, so I have 36 then minus 6 times 6 plus 6. So it'd be 36 minus 36, which is 0 plus 6. So 6 would be a point. 6 and 6 would be right there. Again, this is 1, 2, 3 to the right, so I'll go 1, 2, 3 to the left, and then get you another point right there. So using the line of symmetry is nice because it sort of gets you 2 points for the price of 1. Okay, so there's my quadratic equation here. Now I'm going to graph my line at the same time. So I have the line right here. So let's see, let me graph it in purple. My x-intercept is negative 4, and then my slope is 1 over 1. So I can go ahead and graph it this way. And if you notice, it actually crosses twice, and it crosses at these nice integer values here. So a solution to the system would be positive 2, and then it goes negative 2, that's the y value, and 5, 1. Okay. Okay, and if we went ahead to check this, it should be a solution to both of these equations. So if I put negative 2 is equal to 2 squared minus 6 times 2 plus 6 into the top one, I should arrive at a true statement here. Yep, and negative 8 plus 6 is negative 2. And I should be able to put it into the bottom one, so I'd have negative 2 is equal to x, or 2 minus 4, and yep, that's right. So the first one is a solution, and if you check the second one, which is always a good idea, just make sure, you'd have, well, I know 5,1 is a solution to the quadratic equation, because if I think back, I used that to find one of the points in the line. So let me just check the line below. So is it true that 1 is equal to 5 minus 4? And yes, that is true. So the second one is also a solution to the line and the quadratic equation. Right, so those two are my solutions to my system. Okay, for the next one, it's actually the top quadratic equation can be factored. So it's y is equal to x minus 4 and x plus 4, because it's a difference of squares. So if I set that equal to 0, I would find, and I put out these two equations here, I would find that, whoops, I want to actually have them set equal to 0. So x is equal to 4 is a root, and x is equal to negative 4 is a root. Okay, so I want to plot 4 and negative 4. Negative 4 right here. All right, so that's where it goes through the the x intercepts. Let me find the vertex here. So first let's put it into the form that I need it to be in. Okay, so my a is 1 and my b is 0. Okay, so I'd have negative x is equal to negative b over 2a. So it's 0 over 2 times 1, which is 0. Okay, so I know that my vertex is going to be somewhere along the y-axis, right, because the x is equal to 0. Now if I put that back into the quadratic equation to find the y value, I'd have 0 squared minus 16, so it's negative 16. And actually I should have anticipated this, but it like goes down much further than my graph. So let's just pretend that this is the value that it goes to. So here is my quadratic equation, the graph of it right here. Okay, again, to be more precise in this region right here, I could put some more values in, but I think that I will be able to get the solution to the system without having to do that. Okay, and negative 4 is right here for my line, and here are my points right here, and again, it looks like it's hitting at these nice integer values here, right here and right here. So I'd have 4, 0, and it looks like negative 3 and negative 7. So that looks like they are, that's the solution. So let me go ahead and put this in. So 0 is equal to 4 squared minus 16. So that's true for the first one, because 0 is equal to 16 minus 16. So this is a solution to the quadratic. And then 0 is equal to 4 minus 4, so that's true. So this thing is a solution to both the quadratic and linear function. Let me go ahead and do it for the next one. Is it true that negative 7 is equal to negative 3 quantity squared minus 16? Well, negative 7 is equal to 9 minus 16. So negative 7, and that is true. So let's check it for the second one. Negative 7 is equal to negative 3 minus 4, and that's also true. So both of those are a solution. Okay. And by the way, you are only in algebra 1 or integrated algebra, you're only going to get a situation where if they do meet twice or if they meet once, the linear and quadratic system, they will meet at integer values. So these are nice integer values here. When you get to algebra 2, they're not going to meet at such nice values, but you'll have different tools that you can use in order to figure out what the intersections are. Right? And that's the end of the lesson today.